Question 3a. Find the integral of cos² 4x dx. The following are the marking guidelines for question 3a. For 1 mark, we have correctly rewrites cos² 4x in terms of cos 8x, or correctly finds the primitive of an expression of similar complexity found as a result of an attempt to apply the double angle formula. And for 2 marks, we have correct primitive. Integrating cos² ax or sin² ax, where a is a constant, requires the application of a double angle trigonometric identity. Recall the double angle identity for cosine. Cos2a is equal to 2 cos² a minus 1. Now the question is asking for the integral of cos² 4x. So in this case, we're going to set a equal to 4x, so substituting 4x for a into the identity. We're going to have cos 8x is equal to 2 cos² 4x minus 1. And then we're going to make cos² 4x the subject, because that's what we're trying to integrate, cos² 4x. But it's much easier to integrate cos 8x than it is to integrate cos² 4x. So making cos² 4x the subject, we have cos² 4x is equal to half multiplied by cos 8x plus 1. And we get that by adding 1 to both sides here, so cos 8x plus 1, and then dividing both sides by 2. And that's where this line comes from. Now it's a matter of integrating both sides of this equation. So the integral of cos² 4x dx, which is in fact our question, is identical to or equivalent to half times the integral of cos 8x plus 1 dx. And that's equal to half multiplied by 1 over 8 times sine 8x plus x plus the constant of integration c. The following is the feedback from the Marking Centre for question 3a. Candidates who used the relationship cos 8x is equal to 2 cos² 4x plus 1 usually obtained a correct solution for the primitive function. Most candidates who attempted to use the relationship the integral of cos² x dx equals half x plus a quarter sine 2x were unable to obtain a correct solution.